Hi, it's Raj Bapala, co-founder and CEO of Applaa. As a parent, we want to give the best experience for our kids. I've got two kids, 11 plus, and other one is doing GCSE exams. So we've spent a lot of time and a lot of money for tuitions, 40, 50 pounds a class and math, science, and English, and many things. And also we've tried our platforms and people saying, okay, use Atom Learning, iExcel, and this and that. And they're okay, but at the end of the day, you're paying 40, 50 pounds for them, and it's really not working out. It's just like only one, and again, where do you go for the next, right? And it's just like a simple mock exam practice, it's there are so many things you can do. It's not really a comprehensive feedback mechanism tool, right? That's what I think. I got really frustrated with all these tools, and again, spending with teachers and tutors is not really working out. So here, that's why we built Appla with the vision of actually helping kids as early as, like from year 8 years onwards to all the way to the GCSEs. We've got the whole curriculum built. Again, we've digitalized the whole UK curriculum here. So, and actually we're giving a value only 9.99 a month, £10, right? What is that? Is the cost of a pizza, even less than that. And so we want to give that a best experience for everyone. You can really see from year 4 to year 11, they can see every single subject, math, they can able to look at this lesson. They can practice but understand the concept first rather than writing an exam for the sake of writing. And then you can able to do a lot of practice also. Then, what is this thing? And then you can see the assessment and whatever you wanted to do. And you can do a lot of things again each year, year 4, year 5, year 6, all the way to there, right? And that's about it. And also you can, once you have there, then probably, most people will go for 11 plus, which obviously you can really see. And yeah, so we have built a comprehensive 11 plus past papers, around 5 dozen papers we have. And again, four topics: verbal, non-verbal, math, and English. So you can able to see pretty much everything. You can take exams. Also, you can get the feedback. Also, you can see how many exams you've been taking. And these are the exams I've been taking about reasoning, and also you can really give the feedback by the subject, by lesson, and at least it will give you a really great feedback for the parent and also teacher for obviously if he's having a teacher and also parent and the kid for writing them as well. You can do quite a lot of things as well. So an example, let's take an exam for verbal reasoning. So you can really see that it actually I did an exam math for now before it actually tells you where you got right, where you got wrong. It's really great, right? As a parent, you cannot able to tell, what is the correct answer, right? So you can able to do, and it's brilliant, isn't it? So it just saves a lot of time. A lot of institutions are charging 40, 50 pounds, even for a paper sometimes, cost like that. And we're giving for free 5,000 questions, right? And many unlimited questions and papers they can do, all for 9.99, and they can do practice again if you want to do it. Just simply go and write an exam, and you can able to see submit papers. You can directly see as well, and the results coming through. As an example, let me go back and show the exam as well. So if you see some of the exams what I've done just now, you can see that exam coming through as well. You can really see the results. So it's just brilliant way to actually get the feedback as well as assessments for the kid who is writing the exam and studying, as well as for parents not to spend too much time for them to sit with them and write down exams, and also more importantly the cost. And we'll explain a lot also all of this in subsequent videos. You can also see that as well. I really trust this is valuable, and take advantage of this offer. It's only 9.99, which is a significantly lower cost. Anyone can able to afford it. It's a cost of a small pizza these days, and compared to 40, 50 pounds a tuition class. And I truly trust this is helpful for you. And yeah, sign up at applaa.com/UK, applaa.com/UK, and register for free. And it's 1 month free as well for you guys. So make use of it. And if you're writing the 11 plus exam, all the best. And again, we'll explain further details also in the subsequent videos. Thank you for watching.
Hey everyone, welcome to today's explainer for all you focused 11 plus learners out there. Today, we're going to unlock one of the absolute most powerful toolkits in all of mathematics, algebra. Now, if you've ever looked at a math problem and wondered why letters suddenly invaded the numbers, well, we're going to figure that out together right now. Our mission today is actually pretty simple. Master algebra, build your confidence. I know, throwing letters into the mix can feel like someone just invented a secret language just to confuse you. But trust me, today we are going to crack that code. By mastering a few core, logical patterns, we're going to build your confidence so much that those letters will literally become your best friends in the exam room. So here is our roadmap for today. First, we've got algebraic expressions. Second, solving equations. Third, number sequences. Fourth, using formulas. And finally, algebra key concepts. Let's get to it. Section 1, Algebraic Expressions. Let's lay down the basics. First things first, what exactly is a variable? Well, a variable is simply a letter, usually an N or an X, that represents an unknown or changing number. I really want you to remember that letters in math are absolutely nothing to fear. They aren't trying to trick you. A variable is just standing in for a number we don't know yet. Seriously, imagine it like a completely empty box, just sitting there, waiting for the right number to be dropped inside. Let's break down the building blocks. We've got our variables, and we also have what we call terms. Terms are just the single individual parts of an expression. That could be a number completely on its own, which we call a constant, or a number attached to a letter, which is a coefficient. Think about a phrase like 4x plus 2y minus 5. That right there is an algebraic expression. But here is the most critical thing to remember about an expression. It describes a situation or an amount, but it doesn't have an equal sign. It's just a phrase. It is not a full sentence. Now, often, these mathematical phrases can get a bit messy, right? Which brings us to simplifying by collecting like terms. Step 1 is simply identifying terms with the exact same variable. Step 2 is to just add or subtract them. So for step 3, if we have 3x plus 2x, we literally just add the numbers in front to get 5x. We're just visually tidying up the math. Look at it this way. If you have 3 apples and someone gives you 2 more apples, you have 5 apples. It's the exact same logic. 3x's plus 2x gives us 5x's, all wrapped up in a nice, clean package. Okay, so once things are tidy, we get to start putting numbers into those empty boxes. We call this substitution. Let's walk through the steps for evaluating 2x plus 3 if x happens to equal 5. Step 1, we simply replace the x with a 5, writing it out as 2 times 5 plus 3. Step 2, and this is absolutely crucial, we always follow our correct order of operations, like BODMAS. So we multiply first. 2 times 5 is 10, bringing us to 10 plus 3. Step 3, we find our final answer, which is 13. Honestly, it's just like opening a combination lock. If you follow the steps in the exact right order, it clicks open every single time. All right, moving on to section 2, solving equations. Time to balance the scale. We really need to clarify this because it is a massive 11 plus concept. What's the difference between an expression and an equation? Well, an expression, like 3x plus 2, has no equal sign. It's just a phrase. By itself, it has no specific numerical answer, unless someone tells us what to substitute. But an equation, like 3x plus 2 equals 11, the presence of that equal sign changes everything. It boldly declares that the two separate sides are perfectly equal in value. That equal sign is the magic key that actually allows us to solve the problem and figure out the exact value of our mystery letter. And that brings us to the ultimate golden rule of equations. Whatever you do to one side, you absolutely must do to the other. I want you to picture a perfectly balanced scale. If you drop a heavy weight onto the left side, the whole scale tips over, right? To fix it, you have to add the exact same weight to the right side. We solve equations using inverse operations, which is just a fancy way of saying we undo what was done. Addition undoes subtraction. Multiplication undoes division. We're just working backwards, keeping both sides perfectly equal until our letter is left sitting there all by itself. Let's see how this actually works with a super quick one-step equation. X plus 5 equals 12. To isolate our unknown x, we look at step 1. Undo the addition by subtracting 5. Because of our golden rule, we have to subtract 5 from both sides. Step 2, that leaves us with x equals 12 minus 5. Step 3, a little simple subtraction gives us our answer x equals 7. We've effectively worked backwards and unwrapped the mystery. And the best part, you can always check your work. Substitute that 7 right back into the original equation. 7 plus 5 does indeed equal 12. Perfect balance. Section 3, number sequences. Let's track down some patterns. Think of a sequence as an ordered list of numbers that follows a very strict rule. The most important phrase you need to know here is the common difference. This is the consistent, exact amount you add or subtract every single time to get from one term to the next in an arithmetic sequence. For example, if your sequence is 3, 6, 9, 12, well, you're obviously adding 3 each time. That positive 3 is your common difference. It's the steady, reliable heartbeat of that mathematical rule. So what happens when we need to find a really, really large number in that pattern? You don't want to sit there writing them all out forever, do you? Enter the nth term formula. It's basically a mathematical time machine. The formula is the nth term equals a plus n minus 1 times d. Now, please don't let all those letters scare you off. A is just the very first term in your sequence. And d, that's that heartbeat we just talked about, the common difference. This blueprint lets us jump instantly to the 10th, the 50th, or even the 1000th number in the pattern without endlessly counting up from the start. So the nth term formula gives us the value of any term directly by using its position number, which we call n. But here is a really cool trick. It does something else incredibly useful too. By setting our nth term formula equal to a specific number, we can actually use our equation solving skills to verify if that number definitively belongs in the sequence in the first place. Okay, challenge time. Let's see if you can figure this out. Is the number 50 in the sequence given by the nth term rule 3n plus 2? Take a second and think about how we can apply what we just learned about keeping equations balanced to solve this brand new problem. Let's work it out together step by step. Step 1, we set our rule, 3n plus 2 completely equal to 50. Step 2, time for those inverse operations. Subtract 2 from both sides, balancing the scale, which leaves us with 3n equals 48. Step 3, divide both sides by 3. 48 divided by 3 gives us n equals 16. And here is the magic part. Because our answer for n is a clean, whole, positive number, we can confidently say, yes, 50 is absolutely in our sequence, and it is exactly the 16th term. Section 4, Using Formulae. Let's take a look at some real-world math blueprints. So, what actually is a formula? Well, a formula is a mathematical rule written out using letters that describes the exact relationship between different quantities. Think of formula as the ultimate time savers. They give us a reliable, repeatable way to calculate an unknown whenever we happen to know the other values. They are used nonstop in math, science, engineering, and just everyday life. You've definitely run into some of these important common formula before. Think about finding the area of a rectangle, which is just length multiplied by width, or calculating speed by dividing distance by time. The amazing thing is, once you know these formulas and you know how to substitute numbers in for the letters, which, hey, we mastered just a few minutes ago, you can tackle a huge variety of complex, real-world problems with total ease. Let's do one final substitution, just to show how smooth this really is, using a simple area formula. Area, or A, equals length, L, multiplied by width, W. Step 1. We're given that the length is 8 and the width is 5. Step 2. We confidently substitute those values directly into our formula, creating A equals 8 multiplied by 5. Step 3. Calculate. A equals 40. Do you see how easily those scary unknown variables turn into real, useful, concrete answers when you just follow the steps? And finally, Section 5, Algebra Key Concepts. Let's do a quick wrap-up. Take a step back and look at your 11+ Algebra toolkit. You've completely conquered it today. We learned that expressions are just mathematical phrases without an equal sign. We discovered that equations are perfectly balanced scales that let us solve for unknowns. We used rules to master the heartbeat of number sequences. And finally, we confidently dropped numbers into universal formulae. You went from just learning what a variable is to utilizing fully functioning mathematical blueprints. Understand the pattern, follow the steps, get the answer. Honestly, that is your new algebra mantra. The letters, they're just empty boxes. The equations, they're just balanced scales. And you absolutely have the power to solve every single one of them. So armed with this amazing new toolkit, what algebraic mystery are you going to decode next? Keep practicing, stay curious, and I'll catch you in the next explainer.